Hello, my name is Joe Carlos Sosa Rodriguez, and I, along with my partner Jeremiah Campbell, present to you the treatment of nutrients in urban runoff using a dual media system. Now, before we begin this presentation, we would like to give our thanks to Dr. Batista, who is our supervisor and mentor, as well as our colleague Jasmine Gray for their continued help and support throughout this research process. We would also like to thank the Office of Undergraduate Research for the continued support as well. We sincerely thank all of you. Nevada, along with other states in the western region of the United States, have currently been undergoing a drought. In fact, about 83% of the land in the West has been impacted by this drought in varying degrees. Now, this drought, along with concerns of future climate change events, have increased our awareness in not only the way we utilize and conserve water, but also makes us think about the current water treatment systems that we have, and also makes us think about the overall quality of the water that we use in our daily tasks, such as doing laundry or cleaning dishes, or even using this water as a drinking source. Now, the bodies of water that we rely upon are also prone to deterioration due to a process called eutrophication, which in itself is a result of nutrient pollution. And so in this presentation, we want to talk about the negative effects of nutrient pollution, the objective of our research, and how our research and proposed solution plan to tackle this issue. As we mentioned previously, the main impact of nutrient pollution is eutrophication, which is the rapid deterioration of bodies of water due to an overgrowth of algae that feeds itself on released nutrients. In the context of Lake Mead and Las Vegas, many of these nutrients come from the stormwater drain system. And in this drain system, you can find nutrients such as phosphorus, ammonia, and different species of nitrogen. Now, these species and nutrients have been studied widely for more than 50 years, and some even have their proper treatment systems, such as phosphorus, for example. However, there are still gaps in the technology of removal of different species of nitrogen. Eutrophication, of course, can have many negative impacts, such as making bodies of water dangerous as a drinking source due to high algal toxins, and it also leads to the death of animal life, mainly due to the lack of oxygen. In fact, this is precisely what happened to Lake Mead in 2001 when a major algae bloom was discovered. Knowing this, the objective of our research is to develop a passive system that removes these nutrients, mainly nitrogen, ammonium, and phosphorus, from our urban stormwater runoff. And if this research is successful, this passive system could be integrated into the street gutters and overall stormwater drain system here in Las Vegas. And because it is a passive system, it also means that it will require very low maintenance. And so we hypothesized that this passive system containing two types of media, one being zeolite and the other being zero-valent iron, which we will refer to as ZVI, will be placed in these structures of the urban runoff collection system, and they will remove nitrogen species, mainly nitrate and nitrite, as well as phosphorus from the urban stormwater runoff through a process called surface absorption, which compared to absorption holds the molecules of these nutrients loosely in the absorbent, and it also utilizes a process of biotic and abiotic reduction with the ZVI. Now, to test the viability of this system, we compiled these two types of media into a plexiglass column. We layered the plexiglass column with 100 milliliters of zeolite at the top and 70 milliliters of a mixture of ZVI and sand under the zeolite. The reason why we organized it this way is because we expect the ZVI media to last longer than the zeolite, and so we layered it with the ZVI at the bottom. And we also use a peristaltic pump to pump a synthetic runoff solution that mimics a typical runoff in Las Vegas into the column. The components that went into this synthetic runoff solution was the regular tap water that you will find here in Las Vegas, but we also enhanced it with ammonium phosphates as well as ammonium nitrate so that we could have a more accurate concentration of ammonia and phosphorus that we would typically find in the Las Vegas runoff water. This system was operated with a retention time of 30 to 180 minutes, and this was based on the flow that pass through the column, and the resulting effluent, which we will have in a separate picture, that would come out of the column. Um, it will be collected and analyzed for the nutrients that we mentioned, which would be ammonia, nitrate, and phosphorus. But we will also test it for iron precipitates as well as pH level. This process was also done to the influent, which is the synthetic runoff water solution that we created. And once this experiment is finished, the sample of the materials will be observed under a microscope to see if there are any presence of bacteria. Now, while we have not generated much data, mainly due to taking longer to stabilize our column, we do have some preliminary analysis in previous studies that allows us to keep some expected results. And so we expect that ammonia will be reduced by the zeolite. And furthermore, the nitrate will also be removed or reduced by the ZVI. And we also expect that phosphorus will be removed by the presence of microbes that may grow in the media. As you may see in the first graph at the bottom, this is a study by Bog and Batista, which shows the effectiveness of zeolite in its removal of ammonia in both high and low temperatures. As you can see, it is quite an effective system. And also on the graph that we have on the right side, this is another study by Allred in 2012, which demonstrates the percentage of nutrient removal depending on different filter materials. I would like to mainly focus attention on CVI1, which is on the first row. This is the same CVI that we are using for our experiment, which comes from the same company in Chicago, Illinois. And it was discovered that this CVI is able to extract around more than 90% of phosphate in the system. And so we believe, based off of these analyses, that our system can be successful at greatly reducing or downright removing all of these nutrients. And this is why we also want to test for the presence of bacteria, so that we can also see if it promotes the removal of phosphorus as well as the removal or reduction of nitrate due to iron precipitates.
Hello, my name is Tremaya Campbell, and I will be presenting the discussion, conclusion, and future research topics of our poster based on the treatment of nutrients in urban runoff water using a passive zeolite and ZVI system. Lake Mead provides water to nearly 20 million people in several states and Mexico. As awareness and effects of climate change increase, such as the drought observed this year in the West United States, it is extremely important to keep this body of water free of nutrients to avoid eutrophication. Keeping Lake Mead clean through this passive system will not only bring tremendous benefits to citizens, but also to wildlife. Wildlife such as fish and plants act as natural filters for Lake Mead by eating algae and releasing oxygen through taking in nitrogen species and phosphorus, respectively, but they easily become overwhelmed with the nutrients in runoff water to keep up with cleanliness. It is our goal to help maintain the nutrients before they reach Lake Mead in an attempt to improve our water source and safety. Question 1. How effective is the current two-medium system that we are using? The current two-medium system is very effective. According to field test results that made mixtures of ZVI and activated carbon with zeolite, limestone, and silica sponge-like, zeolite appeared better to be more effective in removing harmful constituents such as ammonia. Favorable results led to pilot-scale trials, which resulted in excellent performance of the zeolite under continuous column operation. Question: will biofilms cultivate in the media, and if so, do they promote nitrate reduction along with the ZVI? Biofilms will cultivate in the media and promote nitrate reduction along with the ZVI. In past research, it has been shown that batch tests for one of the ZVI filter materials exhibited an 88% decrease in the pesticide atrazine. Question: will iron precipitates be formed? Will they remove phosphate? If they do, how efficient is it? Iron precipitates will be formed and help remove phosphate. This has proven to be very efficient throughout research studies. Are there other water Question: are there other water treatment systems that are more efficient, such as sodium modified ion, SMI? There are other water treatment systems that are efficient, such as SMI, when it comes to constituent removal. Compared to the SMI system, which proves to remove more heavy metals, the two-medium system we built proves to remove more nutrients. Excessive of nutrients leads to eutrophication, a process of rapid algae growth on bodies of water that leads to the negative impacts on overall water quality. To attempt to solve this issue, which recently affected Lake Mead, the team created a two-media system consisting of zeolite and ZVI sand mixture that would be integrated into street stormwater systems. This system will mainly target the reduction/removal of nitrogen species and phosphorus. Thank you very much.